So we'll be starting a new section on what's called transformations. Autobots transform and roll out. So we're going to talk a lot about, or excuse me, you're going to see this a lot in tests, the MCAS, etc. And what we're going to do is two things today. We're going to identify what's called rigid motion, so we have to define that, and we're going to look for translations. So by introduction, this is from a book by a guy named Dan Brown. You may have known him for Inferno, which new movie is coming out soon, and some other movies. Anyways, but if you notice this, anyone know what it says? Illuminati, yes. Illuminati. But if you turn it upside down, what's it say? Illuminati. Right. Crazy talk. What's that say?
The Princess Bride.
The Princess Bride. And if you turn it upside down, it says the Princess Bride. So in other words, when you do a rigid motion, when you just rotate this straight around, it's the same thing. That's called symmetry. But the idea of this with many art and, as you see, design here, is if I can just flip things and I get the exact same shape, then I end up, or it says the same thing. It's called symmetry. But what we're effectively doing is transforming it. We're rotating it around. So, what about the letter D? What about the letter D? How can you make other letters just by moving D around? Go ahead and talk to your neighbor about that. So if I were to flip it to the right, officially that's called a reflection. And then we have a B. All right. So we got the, that's how I write my nines actually, but a lot of, actually Europeans write their nines like this. Or, wait, how do they do it? It's like that. Anyways, right, I know it looks like a G. Anyway. All right, so, and then the last one, of course, is if I make it look like this, I now have a P. So notice that one letter is actually four different letters. And if you cut it up a little bit, if I took the leg off, we eventually get an A right there. So there are, when you're doing what's called topography, the art of letter making with fonts and stuff, notice you only have to make that one letter and just do some rotations to it or reflections to it. Because to go from here to here, really all you have to do is, if I rotate it there, now I've got a P. So it could be a rotation, it could be reflections, it could be other things. So that's what we're going to talk about today, how to move things around, and primarily we're going to talk about not changing its shape. We're not going to increase it or decrease it. All right, so that's the first thing right here, a transformation of a geometric figure. Is any function, and when we say function, we like say move it, change the x, change the y, or flip this, etc. That position, oh, how embarrassing. Okay, so that a function that changes the position, so it just moves it left or right, up and down, the size, it increases it or decreases, or the shape of a figure. So if you saw Terminator 2 back in the 90s, I hope you didn't because that's rated R, when the T2 would change shape, morph. All right, so one thing that we're going to look at for the next few sections is what's called rigid motion. Rigid just means stiff. That's what rigid means. So it's a motion that maintains size and shape. That maintains size and shape. So I don't make it smaller, I don't make it bigger, I don't cut off something, I don't mold it, I don't bend it. So we're going to look at what's called a translation today. Learn to spell. Then reflections in a mirror. And the mirror is not bent at all, so you get a magnification. And then last, a rotation, and not necessarily in those orders. Rotation, just flipping things around like we saw with the Princess Bride. Other terms we need are what's called pre-image and image. The pre-image is the original shape. And then the image is where it goes. So, for example, if I have this shape right here, an A, B, C, and I just shift it over that way, like this. Now notice I do want to point out some notation. When you shift, yes, in real life, you can pick this triangle up and move it. and it's still the same triangle. But if we're talking about like cartoons in the old ways of drawing cartoons, where it's now in a different position, it's kind of like it's a different triangle. So instead of calling it A, we say A prime. That's how we read that, A prime. And this one is B prime, and this one is C prime. So the original image, you do something to it, flip it, rotate it, or we just shift it over, left or right, up and down. When we do that, then we have a new plate, a new triangle, and we're going to call it A prime, B prime, C prime. We could even put double primes on those, triple primes on those, depending on how many times I'm shifting it around. All right, so today we're going to look at what's called a translation, and all we're doing is effectively sliding the figure to a new position, up, down, left, right. So we're not rotating it, and we're not reflecting it in a mirror. So here's some fun little way of how we write it. What looks complicated really is not so crazy. The T right here stands for translation. And these here are your instructions, kind of like slope. They just tell you, for the X, you're going to take away 1, and for the Y, you're going to add 4. So in other words, the instructions that it gives, it says translate this object. You're going to go left 1, up 4. So this is kind of like it's kind of like slope, just not in the same order. So it just tells you the new position. All right, so I want to go left 1 and up 4. So all I do is take each point and go left 1, up 4. So left 1 and then up 1, 2, 3, and 4. So my new A is right there, and we call that A prime. Now I repeat the process with B here. Here's B, go left 1 and up 1, 2, 3, and 4. Now notice I don't have to recount, and in a moment we'll show you, we don't have to recount all of them, but I will for this sake. Left 1, right, and up 1, 2, 3, and 4. Right there. And now I have my new shape right there. Now notice I could just apply the rule to one thing, left here and up 4 right there, and then just notice how A and B compare. Just go down 2 and make the mark, and this one's just down 1, left 3, down 1, left 3. So I could have just moved one of them and remapped all the points relative to down here. And that's an alternate way to do it. So at first, what looks very complicated is a very simple instruction. Translation, left or right, up or down, and this is the shape that I'm doing it to. So please take this next one and apply. We're going to graph the image, that's the new shape, under the given translation T3, 3 of MNOP. What I did on this one was simply follow the instructions just for the M. I went right 3, 1, 2, 3, and up 3 right there. And then I just resketched the exact same thing. I redrew all of that up here. Now I changed it from M to M prime, etc. So in example number 2 on page 2, we're going to write the rule that describes the translation. And notice here, we're going to go from, generally speaking, since this is my A and this is my A prime, all I have to do is go from 1 to its corresponding. So here's the pre-image going to the image, and that's all we have to do. Since the shape is not rotating or reflecting, I know that it is going to be a T. Down here as a subscript, I'm going to put this sort of a bracket. It's called vector. When you get to physics and pre-calc stuff, that's where we talk about what's called vectors. So this is officially a vector notation. All we're doing is saying, how do we move one point and remove everything? So let's see here. This goes right 1, 2, 3, 4, and 5. So that's a positive 5. We go up 2, 1, 2. So that's a positive 2. So I have the instructions, and now I'm just telling to what am I applying it, and I'm applying it to triangle ABC. So You are visiting Washington, D.C. from the American... Whoa, there should be 2 periods there, sorry. From the American History Museum, you walk 5 blocks east and 1 block south to the Air and Space Museum. Then you walk 8 blocks west to the Washington Monument. Where is the Washington Monument in relation to the American History Museum? As we work through this one, number 1, you could just put H at 0, 0, and then estimate where A is going to be. 5 blocks east, and then 1 block south, something like that. And then the next one says that I'm going to go 8 blocks east right there. And effectively what we're looking for is this right here. What's its new relationship? But again, as we see that my blocks, etc., each block's represented an x value. So this one here is x plus 5. Then this one here is a minus 8. The block south here right there is a y minus 1. So essentially here, when we connect those two, that translation, what's its relationship to the original? It would be -3, -1. Or you can say 3 blocks west and 1 block south.